Here's our starter for today. 1, draw a velocity versus time graph for the equation from 0 to 5 seconds for v equals 2 meters per second squared times time plus 3 meters per second. And then determine the area of the graph for these 5 seconds. This area represents the blank of the object. Determine the average velocity for the object for these 5 seconds. Use the equation average velocity equals delta x over delta t. And then what is the simple average of the final velocity and the starting velocity? And use this, and hey, you're going to, hopefully you saw that they were the same thing, which is a big deal. All right, anyway, let's do this. So for number 1, well, let's see. For 5 seconds, I need to scale this properly. So we'll just go 1, 2, 3, 4, 5. On my own screen. Very good. Okay, so 0, 1, 2, 3, 4, 5. I'll go to 6. This is time in seconds. And now, I need to be able to scale this. It'd be nice to know what my maximum velocity is. I'm going to start at 3, and then I'm going to go for 5. So 2 times 5 plus 3 is 13. So I want to go to 13. So I certainly don't want to make this 1, 2, 3, 4, 5, 6, because I'm going to run out of room. But I will do this. 2, 4, 6, 8, 10, 12. Okay, and then that'd be 14. So this is velocity in meters per second. And then t equals 0. It'll be 3 meters per second. So 2, 3, so it'll start right there in the middle. Now, it says just to graph this equation from 0 to 5 seconds. So I know that at 5 seconds, I'll be at 13. So here's 5. So 13, here's 12, 10, 11, 12, 13 is right there in the middle. And all I got to do is connect these with a straight line. Because this is, after all, a linear equation. Now you could go, well, let's see, plug in 1 second. Well, then you have 2 plus 3 is 5. So 1 second. Oh, look, it's right there on the 5. See? This is 4, this is 6, so 5 is right in the middle. Go to 2. 2 seconds, 2 times 2 is 4. 4 plus 3 is 7. Oh, look, it's right there at 7. So, you could plot every point if you want. 4. It should be up to 11. Yeah, like that. It's right at the 11. Isn't that nice? Now, so that's number 1. And then number 2. So let's just write the equation down. 2 meters per second squared times time plus 3 meters per second. Now it says, for number 2, it says determine the area under the graph for these 5 seconds. And, well, now there's a couple ways to do this. I'll do it the way that most people would do it. The area underneath this graph, it's all of this. All of this. And you don't have to do it like what we did in assignment 1 where we, measured the area for each second. We don't need to do that. We just need the total area. So I'm going to draw a rectangle and a triangle. So here's this rectangle. And this rectangle, and I'll just go like this, the area of the rectangle is equal to, well, the base, which is 5 seconds, times the height, which is 3 meters per second, and that's 15 meters. So really this represents my displacement, or how far I went, or my total change in position. Then you have the triangle part, this part right here, and the triangle part, well, it's 5 seconds, but you go from here to here. This is 3, and then what is this? 13. So from 3 to 13, that's a change in 10 meters per second. So what's the area of a triangle is 1/2 the base times the height Oh, look, the seconds cancel. 5 times 10 is 50, divided by 2 is 25. And the units left over is meters. Oh, and if I go off screen, please let me know. So the total displacement, the total area underneath the graph is you just add these two together. So that would be 40. 40 meters. That's my answer. Now there's another way of doing it. What kind of shape is this? It is a trapezoid. And a trapezoid, it's a trapezoid on its side. So it's the average base times the height. So what's the average base? This is 3 meters per second. That's this base. And what is this? This whole thing here is 13 meters per second. Got to divide that by 2. It's the average base. And the average base is you add the bases and divide by 2 times the height, which is 5 seconds. And 13 plus 3 is 16, divided by 2 is 8. So that's 8 meters per second times 5 seconds. And you get the same answer, 40 meters. Isn't that lovely? So you could have done it either way. And that's how you do number 2. Now number 3, it says determine the average velocity for the object for these 5 seconds. Use the equation average velocity equals delta x over delta t. So 3, we'll say the average velocity is delta x over delta t. And well, what was delta x? Oh, and you know what? I forgot to write down my answer for part 2. The area represents the what? Displacement, or how much I changed my position. Delta x. Don't say distance. Now, so delta x, well, we calculated that. That's 40 meters. And then delta t, what is that, 5 seconds? So what's 40 divided by 5? Is 8. 8 meters per second. Now let's take a look at number 4. What is the simple average for the between the final velocity and the initial velocity? Use average velocity equals v plus v naught divided by 2. Now let's take a look at this. If we said that the average velocity is equal to our final plus our starting velocity divided by 2, well, our final velocity was 13 meters per second. Our starting velocity was 3 meters per second. And we divide that by 2. Well, 13 plus 3 is 16. 16 divided by 2 is 8 meters per second. Now, this fact that the average velocity, which, remember from Unit 1, average velocity is defined to be delta x over delta t. But it also happens to be the simple arithmetic average of my final plus my initial velocities. Final velocity on the graph, here's the final 13 meters per second plus the initial 3 meters per second divided by 2, you get the same answer. Folks, that is only true. The fact that you could do this is only true, where this also is the same thing as this, when what is true? It's only true if the velocity graph is a straight line. If the velocity graph is a straight line, well, you have a trapezoid. Look at this. See this? This is the average base. So another way of looking at it is this. Take a look at this graph up here. Here's my average velocity. Now, I want you to really think right now. This requires concentrated thought. Here I'm saying my average velocity is 8 meters per second. What that means is that if I go 8 meters per second the whole time, I'll go just as far as I did when I started at 3 meters per second and gradually increased to 13 meters per second over that 5 seconds. And look, watch this. This is very cool. Here's 8 meters per second right here. What if I went 8 meters per second the whole time? How far did I go? What was my displacement? Well, that would be the area underneath here. And 8 times 5 is 40 meters. But look at this. Look at it in terms of areas. When you take a trapezoid like this one, and you go right in between, what's exactly in between 3 and 13? 8. 8 is exactly in between them. If you go 8 the whole time, what do you notice? Look at this triangle right here. What can you do to this triangle? Fits right in there. See how the area of this little triangle, if I just rotate it around, will fit directly in there? That will only happen if this is a straight line. I mean, if this is some kind of crazy shape like this area won't fit in there. So it won't be the same displacement by looking at areas. This is going to be a big deal in, well, I'm kind of anticipating what we're going to be doing next time. But this is what's going on. Are there any questions? Okay, that is all.